So, hello, this is Pradipta, and this is the highlight session of Hackathon, and this is the complete pipeline. Okay, let me first explain you from the start. So, a user comes, a query enters, the supervisor agent gets activated. It extracts the entities. This is the like US state codes, ROIDs have some particular format. So that is being extracted, and we have intent-based classification. So basically, it classifies the query based on the intent. Let's be try, stack, critical, and everything. So these are the three things mentioned. Okay, so basically in those 5 intent handlers there are 3 main agents: pipeline agent, quality agent, and the query pipeline. Okay, so pipeline agent, query agent, or quality agent are basically the procedural memories. Okay, so this is the procedural memories, and the query pipeline is the actual general path, okay, of any of the query. So the pipeline agent tools then goes to the formatting agent, and the final response is being generated. So, okay, in the query pipeline, the architecture is there is a classifier which handle 3 paths, that is SQL path, vector path, and history path. History path is the episodic DB. Okay, and based on the query comes, the query basically gets parsed and see that basically how many types of, maybe 2 SQL queries and 1 vector query may be required. So vector query is basically the semantic query. Okay, and so basically 2 things are there, and in the LLM there is multiple tools here, which includes the web search tool. Okay, so we have configured the tools in the LLM. Okay, so here is an interesting thing. So there is a refinement loop here. Okay, so the refinement loop for the SQL path is like so in the SQL there is a self-correction SQL loop, which majorly there are many columns, and we have feature engineered every of the columns. Like the columns, there is a generation in the column, and there is a gen in the column. So we in the generation we have unified it, like everywhere gen is used with a capital casing for all the columns, and though this will stop basically break the hallucinations of the SQL. Okay, and there is after then there is sufficiency judge. So basically it takes that whether the context we have gathered combined is sufficient or not. If not sufficient, then it generates 4 things: refined SQL, refined vector, or refined history path. Okay, so based on the refined things, refined, and one is missing. If the sufficiency judge can analyze that what is being required, then it goes to the sufficiency. Then it goes back to which path is required. And if it's missing, then it generates a special kind of SQL query which sees over what is being required. Okay, and then it goes to format and then the final response. So some key things. So we have added a SQL hint in the is conversation. So is conversation basically handles those queries where like we say hi and everything. So basically not triggering this complex architecture and just bypassing it. Okay, and the SQL hint basically before knowing what is required. So we add a SQL hint before that. If this is a SQL hint, then the SQL hint is basically a SQL query. Those SQL queries run, and that means if it's having SQL hint, that means the particular query can be resolved by a SQL path only. Okay. The main and anything is parallel execution. To reduce the latency, we have parallel path execution, and as I've said, there is a self-correction loop for the SQL. Okay, judge and efficiencies I have explained, and apart from that, the episodic DB, we have 3 ChromaDB collections. Okay, one of them is being investigations. Okay, investigations is like whatever we have interacted, so based on whether it's useful or not, it shows in the investigations. Okay, this is the history DB of the ChromaDB. Okay, and first, why we are using SQLite? Because for the aggregation, obviously the ChromaDB supports only the vector thing, the vector similarity, but not the aggregation. So we are integrated SQL here, but we can also integrate Pinecone for better architecture here. Okay, so now let's start the dashboard. Okay, so these are the procedural memories. Okay, what we have defined the procedures, and meanwhile let's select market report for tennis. Okay, and for tennis you can write tennis also. Obviously it will be auto detected. Meanwhile, let's see the dashboard. So here's the dashboard. Okay, these are the total number of roster operations. What are the stuck number of roster operations? In the roster operations also, like for the stuck roster operation, we have obviously feature engineered multiple like using multiple columns to get the stuck arrows. Okay, like some maths has done, and apart from that, it is failed roster arrows, the red flag roster arrows. These are the proactive alerts. Okay, this is the root cause analysis, the recommended actions. Okay, these are the retry effectiveness, you can see. Okay, and this is the pipeline health report, and these are the stage bottlenecks. In what stage, what is the bottleneck, how many stuck, how many failed, and other things. This is the market context. Okay, and these are some of the charts. So let's see the response. So as you can see, there is a tennis there. This is the output, and this is the success trend graph of the tennis. Okay, so this is the create graph tool along with web search tool. I have said we have created multiple tools. This is one of the two. Okay, so let's select a complex query. Meanwhile, I'll explain you the memory. Okay, sorry, meanwhile I'll explain you the charts. Here's the chart. Okay, the output has also come. So first I'll explain the chart. This is the pipeline stage heat map. So there are multiple organizations, and based on the organization, what is the basically in what pipeline it's been failing, and it's the success trend. Okay, this is the retry effectiveness by each market. Okay, then which are the stuck roster operations here. Okay, and as you can see for this particular query, we have 4 tool calls, 2 SQL calls, and 1 knowledge base, which is the semantic memory. Okay, and 1 is the web search. Okay, and this is the output. Let's take a more complex case. Okay, meanwhile I'll show you the memory. We have asked around 2 questions, I guess, now. Okay, so this is the 2 cases we have asked. Okay, this went to the episodic memory, and apart from that, this is the procedural memory. Okay, we have this number of cases. Okay, and yeah, so this is the semantic memory. Okay, these are some of the data we have defined. Okay, so the output has already came. So this is the SQL query which it ran. Okay, and this data. So asking out episodic, what was the last question? So this is the semantic query. We have added some data, source system data, some more data, and every time a thing is okay. So this, as you can see, the memory is being called. So basically, in the case of so we have some data here. Okay, every like what does it mean, what are the log meanings, what is the source systems. Okay, and every time you insert a query, so we have a importance score here. So based on what type of output it is giving, the importance score is calculated, and that importance score is also used while retrieving also. Okay, so based like highly good defined web search is done, so that importance score will be higher. If a good SQL query is run with some maximum major joins, discovering some good trend, good insights, so that will be added. So even you can see this question we have asked about the federal question here. Okay, before so this federal question was asked, in which multiple web search was done and everything, so that is being added. So I have shown you the memory, the procedural call, and also the semantic call. Okay, the knowledge is